Good morning everyone, my name is Sam and this is codingwithsam.com. So today we'll continue with our previous video. Just a quick recap on that. So we had our square root calculator here. We're able to type in a number and obviously we get back the square root. However, there is a problem with this. If we type in some text, unfortunately we get this nasty exception. It's not good for our customers. We can't ship it out like this, it crashes. So let's fix it. So here's the code we had before, and we can see that obviously it's inside this calculate method that the problem is occurring. And if we examine a little bit closer, culprit is this float function. So what it's promising there is to take any value and convert that into a float. If we think about that, we can't really convert a string into a float, so it throws an exception. We want to get rid of these exceptions, but we want to do it in a functional style. So we want to use more like the option types that we'll look at, rather than using if statements and null checks. So let's start by rewriting this float function, and we'll also in the method we'll encapsulate this notion of failure. So we'll name a try float, and we're going to use a pattern matching on this. So we're going to try parse on the value. So pattern matching means that we have to handle each case. In this case there's two cases. So there's the happy case where we have a value, and then there's the unhappy path where we have no value. So this kind of encapsulates this. We'll finish off this function in just a second. So just to clarify here, we've got a function here, try float, takes in a string, in this case x, and then we're using that to convert that to a float. So try parse into a double. True means we've got the value and there's the float there. False means it failed to convert and we don't care about the value because obviously it's not important there. So the same underscore is the same principle here. So now it's time to return this. So the last value of a function is always a return type. In this case it has two branches, but these must be the same type. So an option type has two cases. The return type will of course be an option. So in this case we have a value, so an option type represents a box. Either there's something in it, in this case sum and our float that we've just parsed, or there's nothing in it, so that's the none branch. If we look at our function now, you can see that FSharp is using its type inference to work out what these things are. The try parse method is what's providing all the information here. String is the input and float option is the output, and again we can see that if we look at try parse, we can see that we've got our string there on the input and the result there is the float. So that's what's providing all the information for the compiler to work out how this method works. So that's off to a good start. Let's use it. So we can take that, we can update this one here. Excellent. It looks good, except we've now got a compiler error. So this is good. The compiler is keeping us safe. It's telling us that we're not being logically consistent, that things don't quite match. Math.square root operates on a float here, which is what it's saying down the bottom there, but we've provided it a float option, which is exactly true. We've just done that. So the way to fix this is we want to run the square root function, but only if we've got a value. So if we don't have a value, obviously there's no point in running it. We can't do it. You can think of this as we want the equivalent of an if statement, and FSharp of course supports that, and that's called the map operation. So that's what we have here. So map will run the function only if it has a value. If it doesn't have a value, it won't run it. So the signature might look a little bit confusing if you haven't seen it before, but mapping is our function to apply, and option is the value that will be piped in afterwards, and the summary there explains exactly what I've just said. So that looks like it compiles now, everything looks good. There is actually still a problem with this, but we're going to run it anyway, and we'll see what we've changed. Cool, so it's at least running now. Let's see if we've fixed the exception. You can type in hello, and it hasn't crashed. So that's a good sign. It's just done nothing, which is probably not the best, but it hasn't crashed. And now let's look at the happy path. It hasn't crashed, but it hasn't quite done the correct thing either. It's printed out the actual option type with the value in it, which is not really what we want. So let's just quickly fix that up. The problem here is a similar one to what we had before, only it doesn't throw exceptions. The string value here takes in any type and then converts it to a string. For most cases this is fine. In FSharp it actually has very good to-string conversions, so that's why we actually get some parentheses 7. If you do this in many other mainstream languages, you'll just get a memory address. However, it's still not good enough. So the best way to start with is to actually treat the function so that it can't error out anymore. So we're going to type that in as to-string. What we're going to do is we're going to constrain it to be a float, and then we're just going to do the same thing. So now it's not possible to get this wrong, because another compiler can help us out. So we're just teaching the compiler a little bit more. And in this case we get an error because naturally we've got a float option here, but we're given a float to string. So this again doesn't work. Following the similar practice that we did before, so it's not too hard to see, we can option.map. And now we've just pushed the error slightly further down the chain. In this case we now get an error saying, hey, it takes a string. You can see the bottom argument there, so string to unit, but we've given it a string option. So that's this value up here, that's a string, and we're providing it a string option. So the way to fix this is to use a function option.defaultValue, but in order to use that you will need to update your fsharp.packages. So if you open up packages and you type fsharp.core, you'll be sure to select 4.1.8 and then update the package. Unfortunately, higher versions than 4.1.8 don't work. So now that that's installed, we can now go option.defaultValue, and then we can just provide it with a string. And in this case, I'm actually going to type in error here, just to make it a little bit more readable output. So let's run that now and see that we've fixed all the errors. So the app appears to have started up fine, which is a good sign. So let's try the unhappy path, and we get the error. That's a good sign. And now let's type in the happy path, and we get our result. So that all is looking much, much better. However, let's just look at a couple of other ideas. What if we actually type in, say, 0, the edge case? Okay, that's working, that's good. What about a negative number? Nan, okay. We can maybe make that a little bit better, and also when we type in the text here, we can see that, you know, we type in anything, we just get error. We don't get any meaningful as to why that failed. Obviously we as developers know that mathematically you can't convert or take the square root of a value, but our users might not know that. Think about a child. What if a child was using this? Assuming they can read somewhat. So we kind of want to fix those things up. We'll cover that in the next lesson, but for now let's just look at a few cleanups that we can do here. So if we look at this, we've got option.map here, and we've got option.map here, and we're repeating those values. If we didn't want to do that, there is a possible way to reduce that. So we can actually take that out, and what we can do is we can use the double greater than signs here to compose these functions together. So this is called function composition. And what we're doing is we're stitching these two functions together first, and then we're running option.map on them. This is a purely syntactic change. The outcome is the same. The code will do exactly the same thing. It's up to you as to which you prefer. Again, we're all just manipulating functions here. Lastly, sometimes with F# it's generally seen to lay out the values as follows. So now it's a pipe chain that you can read down. That's all. Next time we'll look to update those error handling and capture the reasons why the errors failed. And we'll also get rid of that nan value. Thanks for watching. This is Sam with codingwithsam.com.